This is example 6 of the inverse Z transform. In this particular example, we are dealing with a HZ that have a complex pole. Where would you see a complex pole? Is that when we have, let's say, up to second order, and when you factor this quadratic equation, you realize that it has a complex pole. In our case, this factors into a complex conjugate of each other. So what you realize is that this complex conjugate of each other's pole will result in a cosine or a sine. Okay, let's try this example. So let's begin. We have an expression 2z times 3z plus 17 over this denominator here. So we have a proper rational function because the numerator has power of 2 and the denominator power of 3. In this problem, we are using positive powers of z here. Positive powers of z allows us to do factorization more easily because we are more familiar with it. So what do? Well, we are interested to factor z squared minus 6z plus 25 into this first. Now again, when we are playing with positive power of z, the first trick is to do this, is to move one of the z to the left hand side so that we have xz over z, because we have to move the z at the denominator to the right hand side later. So this guy is actually the same as the top, except that we are moving this z here below. So the numerator becomes 2 times 3z plus 17. The denominator remains the same. Now, then you do partial fraction expansion. From here to here is, of course, partial fraction expansion. You figure out how to do this by yourself. It is tricky and it is highly mechanical and easy and error prone. So what you should do is, whenever you have found the answer, you perform the combination back so that you want to check your answer. Now, once we are in this form, this has the lookup table. This is simple. We can move the z back here. So now it is x of z equals to 2 times z over z minus 1. So the z also goes to this side for the two expressions here. Okay, so when we are in this form, then there is a lookup table. So what is this expression? In h of n, it is 1 to the power of n un. 1 to the power of n is simply constant, so it's 2 times unit step. So we have 2 times unit step. So 2 here and unit step. So that's the first expression. What about this second guy here? Now it's very complicated. We ask you to refer to this ZTransform lookup table. So in the ZTransform lookup table, you first identify that you have a complex conjugate pair of a pole, which we have. Okay, so this is a complex conjugate pair of pole. By complex conjugate, is the real part is minus 3 and the imaginary part is minus j4, sorry, and plus j4. So what's happening is z equals to 3 plus j4, and here is z is equals to 3 minus j4. So one is a complex conjugate of the other. So this is z star. So this is z at one is pole position. This is 3 minus j4. It's complex conjugate. So this is what we're talking about. What about the numerator? In the numerator, again, in this example, we have a real number here and a angle here. And this angle, interestingly, is also complex conjugate. So the magnitude is the same, 1.6, but the other guy is plus j is 2.246. Here's minus j 2.246. So you realize that the roots are complex conjugate. The scaling value is magnitude have a positive, have a complex conjugate pair of angles on the numerator. Now the lookup table also looks the same. You realize that it has an angle here and a minus angle here. Okay, so it's expecting this form. If you don't have this form, you can't use this x of z to get back to you the x of n. Alright, now you realize that here is 0.5 r. So now let's begin to identify 0.5 r. Then here is this value here. So this guy is 0.5 r. This guy here is theta. Okay, and this bottom here, this guy is gamma. So we have gamma, theta, and r. Okay, gamma, theta, and r. Once we have it in this form, then gamma is a complex number. You can represent it into a magnitude and phase. So it's magnitude gamma and phase beta. So you realize that this equation has 4 variables: gamma's magnitude and gamma's phase, 0.5 r and theta. Together, you can substitute into this equation here. You are not required to solve for this equation. We can use a lookup table unless the question asks you explicitly to identify why this xn will produce this xc. So let's substitute. So beta is here. It is the frequency of the signal, radians per sample. How many radians per sample? What about the other gamma? Absolute gamma is here. So these two values is absolute gamma to the power of n and beta times n. What about 0.5 r? 0.5 r becomes r here. So although we are given 1.6 is representing 0.5 r, later on r will become 1.6 times 2. Alright, what about theta? Theta is the phase, so we put it here. Now, so once you have identified these 4 variables from this expression, you can substitute, and now let us see the 4 variables. Okay, so we have this is 2 times 1.6. It's 3.2. This is absolute of gamma. This is the beta of the gamma. This is theta, and this is one more. This was r. This was 0.5 r. So you go and substitute these 4 variables, and you will get these equations for the cosine. Now you might be wondering which one to choose, right? Because there is two complex conjugate. So what I would advise you to do is to draw where they are. So this is z. So first draw a unit circle. And now we are going to substitute z equals to, so this is z equals to 3 plus j4. This is z equals to 3 minus j4. So where is 3? So this is 1, 2, 3. So now we are going to draw j4, so which is here, and minus j4, which is here. So if you really want to, you can draw 2 triangle here. So this is z equals to 3 plus j4. 3 minus j4. Now the trick is always look at the positive pole. So this pole is, let's call this ZA, and let's call this ZB. So who is ZA? This guy is ZA. This guy is ZB. So we are always looking at the theta from ZA, the guy that is on the positive J. Okay? So because you realize that there is a, you'll be wondering which theta to use, because one of them is minus and one of them is plus. That's the idea. Okay, so with that, then I think I will end this difficult examples. The idea is that you must copy this equation somewhere, and when we are given this expression, you must be able to find these four variables and substitute them correctly for x of n. Thank you.